Now let's look into data persistence or persistent data, which is a day-to-day challenge in dealing with. So, so the aim here is to keep the data with the container in spite of containers in spite of the container was killed and removed. So containers are generally known for its volatile nature. That's because containers are disposable. The way you make any change in a container is always through the image. So if you want to add a package or a configuration file or any serious change you want to do in the container, you don't log in and make changes. That's because they are disposable. So we delete them and we create an updated container from an updated image. And for that reason, they are called as volatile. So if we store any data in the container and if we have to replace it during upgrades, rolling upgrades, it's going to remove the container and create a new container. So when it removes the container, all data will be also gone with it. That is the problem here. So now how to solve this challenge? So that's the reason I say a Docker challenge, day-to-day Docker challenge. So how to solve this challenge? That is using persistent, how to keep the data persistence, how to keep the data persistent. So let's take one example. What if you have a container that is stateful like MySQL that needs a database? It stores the databases and reads from the database. If you happen to replace that container, all data will also be gone. All data will also be gone. So what will you do? What if this happens? What will you do? So you have to solve this issue. So how can we solve that issue? That we are going to see in this session. So as you develop software with Docker, you will also discover you have various needs that arise. You may grapple with the running graphical user interfaces from a container, running into confusion around the Dockerfile, build cache, so want to manipulate your containers directly while in user interface. So wonder about the lineage of your image, want to reference data from an external source and so on. So here so I will take you through techniques that show you how to handle these challenge, how to handle this challenge and concerns that may arise. So think of it as a Docker toolbox here, because the persistent data, the volumes or the data that to be stored permanently, this is a challenge. So that's why we have to deal with it. So the Docker only comes up with different solutions. We are going to discuss various solutions, not one, 4 to 5 solutions I'm going to provide it to you. So first one, will begin with volumes. Containers are a powerful concept, but sometimes not everything you want to access is ready to be encapsulated. You may have a reference Oracle database stored on a large cluster that you want to connect for testing. Or maybe you have a large legacy server already set up with binaries they can't easily be reproduced. When you begin working with Docker, most of the things you will want to access will likely be data and programs external to your container. We will so I will take you from the straightforward mounting of files from your host to more sophisticated container patterns, so the data container and dev tool containers. Much of the power of containers comes from the fact that they encapsulate as much of the state of the environment file systems as is useful. So sometimes though you don't want to put files into a container, so you might have some large files that you want to share across containers or manage separately. So the classic example is the large centralized database that you want your container to access, but you also want other clients to access alongside your newfangled containers. So the solution for this is Docker's mechanism for managing files outside the lifecycle of the container. Is the solution is volumes. Although this goes against the philosophy of containers being deployed anywhere, you won't be able to deploy your database dependent container where there is no compatible database available to mount. So it's a useful feature for real world Docker use. So let's take one example here. So the problem here is you want to access files on the host from within a container. So, and solution is we are going to use Docker's volume flag to access host files from within the container. So to make data persistent, we have few options. I will take sticky note. Out of which persistent the first one is volumes mount and second one is bind mount. So the volume mount is the best case example for to access files on the host from within a container. So if a container wants to access some files from the host, in that case volumes will be better. For databases, bind mounts would be better because you can attach whatever data that you want to that you want your container to be accessed from inside your host, that can be attached directly, put in volumes, and that can be used by the host, used by the container. So this is a first case, volumes mount. That case we are looking on the screen now. So for that we need to use volumes flag to access the host files, and this is how it looks. For this is only for volume mount. Of course this is for database. So let's make it graphical now. So now let's look into this volume case. If you see, you have a container, on the other side you have MySQL process which is running. Now this is where db tables. So this is the directory inside the host machine. Now you want to connect, see, the where db table directory sits on the host file system, and you want to connect this with the where data1 directory which is running inside the container. So here the container running on the host maps the where db tables data which is inside the host machine with the /where data in the container. So that's what a mapping, that's what we call that's how we make a data persistent. Now what type it is, that we will that we will see in examples. And here we will see the MySQL process, and a MySQL process affects data on the same directory. So here so whatever we have discussed so far in our last slide, that we are going to demonstrate here. So how to solve that challenge. So let's take one hypothetical situation. The question is, What if you have a container that is stateful like MySQL that needs DB? It stores databases and reads from database. Just imagine. Of course, if you have a database, let's take one example. It would be much clearer. Let's take a WordPress application. So WordPress application, the backend for the WordPress application is SQL database. So in that you can log into that WordPress application and you can write your blogs. Okay, for past 1 month you have written 15 blogs. Okay, you have written 15 blogs. Now after the 1 month you thought like I will add a few more additions to user interface so that you have added those modules to your source code. Now you want to upgrade, you want to roll the updates of new features into your WordPress. So how will you do that? You will go to the server and you will stop the container and you will remove the container, and then you will remove the image also. Then you will with the updated source code you will build a new image, and then you will spin a new container out of the new build image. Okay, everything is fine, brilliant, super. But the issue here is what happens to that 15 blocks that you have written? You tell me. Yeah, tell me, Ray. What happens to that? It will go. It will. It will completely gone. It will be gone completely. You won't find. Yes, you won't find. You'll never find, because that will be inside the MySQL database. The MySQL database is inside the container. So if you remove the container, if you delete the container, your blocks will be gone. So how to solve this? Imagine this is 15. If it is 1000, what will you do? That's where the pain comes. That's where the offers few solutions. So one of that, to solve this kind of issues, so Docker has come up with two types of solutions. One is volume mount, second one is bind mount. So the issue here is it these the data in the container does not persist for a longer time, and rollover. Moreover, it will be difficult to get the data from the container. So if you are using it, so like you are making code changes, like the same example that I have seen told, right? And we have seen it in the separate uh, directory. So it stores its data, so it's tightly coupled with that directory file system structure. So if you want to move the data somewhere else, it's very difficult. Or like, see, you may say that now, okay, we'll do one thing before we stop, and before we remove the container, we will copy all the data and we'll put it in your host machine. No, that's a container. It's very difficult, very difficult to transfer all the data. Forget about the difficulty. It's impossible. We cannot do that. So that is the reason we should have a ways to do that. Those are the ways. So we have two options to persist the data, to make to make the data persistence, that is volume mount and then bind mount. So what is volume mount? So volume mount is very simple. So we Docker will create an directory of directory where data can be stored. Okay, this is called volumes. And how will it how will it create? It will create when we have to say Docker volumes and give the volume name. When you say this is gonna create a volume directory inside the, I'll show that also, ls cd var lib docker. You see that volumes directory. Let me bring this up here. Let me keep it here. So you could see that volumes directory, when you say docker volumes create volume and create a volume name, then that volume will be created inside the here inside this volumes directory it's gonna create. So that is one way. So the location will be decided, the location is default, you cannot have the location wherever you want, the location is remains same, that is where lib and docker volumes. Here you will have your volume, at this part you will have your volumes. Okay, this is called volume mount. This will be handled by the docker only. So that is one way, and the second way is pretty simple. So uh, wherever you want to store the data from the container continuously, so what you have to do is you will create your directory, make dir inside your host machine, and then map that exact directory, that's absolute path you have to give, absolute path of directory with the directory of the container from where you want to collect the data continuously. That's it. These are the two tabs. The first one is default volumes, and it will be handled by the docker, and here everything is done manually. Wherever you want you can create your directory. So these are the two types of uh, volume mounts we have. So these are the two ways to make data persistence. In addition to that, we have two more ways that we are going to discuss in next slide, but for now we are going to demonstrate these two things. So that's the reason. So let's do the bind mount first. So but before that I want to tell one more thing. So for us, if you take the volumes now, so whatever data you store in a container at separate directory, you will attach it to a directory, the volumes directory. So all the data from the container directory will be going to the volumes, which is in our host machine, that is in var lib docker volumes. So it's safe on our, the data will be safe on our host machine. So all the volumes will be in this location only, var lib docker volumes. Whereas bind mount, if you see the bind mount, this is mostly used when you want to make changes to the container data. Okay, this is bind mount. The best example for the bind mount would be if you want to change the source code continuously. Okay, so in that case you can put your data here, or you want to get some data continuously from there. So in that case it will be good. So like and this is mostly when you want to make changes to container data, you can do it from your host machine directory, and this will be reflecting into your container directory. So you can select any directory from your host machine and map it. So by the way, as I have told you, volume is also similar. The volume mount is also similar, but the volume is managed directly by the Docker, but it will put the directory in this var lib docker volumes. So if you take the best use cases, let me take the best use case for volume mount is database. Perfect to store a database. Okay, whereas for bind mount, the best use case is to write, to do the changes in source code of in the source code of application. Okay, you will do the changes in our host machine, that will be reflected in the container. that's the best case, will do the changes in host machine of host machine where the where the where the directory the directory which is binded with the container directory, so in host machine, and that will be reflected inside the container. So in that way you can update your source code there. Okay, these are the best two ways. And now let's do our experiments. Our first example we are going to consider is bind mount. Okay, we will start with bind mount. In this persistent data, the first example we will do is bind mount. Let's begin with bind mounts experiment. So now let's get into the instance. Okay, Docker server sudo I and clear the screen. So if you see here, now first we are going to see bind mount. So we will specify a directory path in our host machine that will be mapped with the container directory. So the container, because we are using, okay, let me write that, it would be much clearer for you guys. So okay, service database that we are going to use is database, that is MySQL. This is the container I'm gonna use. And so container directory where data stored would be where, this is inside the container, where lib MySQL, obviously MySQL. So this is what, okay, this is the information about a container. So now, so with this information, so the first step should be to create, because it's a bind mount, so we have to create a bind mount directory. That's it. After that you have to spin a container with bind mount mapping. That's it, it's that simple. So let's do that now. So first what I will do is I will pull the image first into my, so at this moment no images are there, yes. So now I'll pull the image first, docker pull, and this is kubecheren, and my SQL version 1. So I'm pulling this image. Once the image has been pulled, then yes, docker images. So now we have our image. Now let's execute our steps first one by one. So let's create our bind mount. So where do you want to create your bind mount? I will create now where I am, pwd. So I'm in a, okay, / root user. I will do ls. So snap, nothing else is there. So only snap. So I will create directory here, make dir, and then the directory name is bind mount directory. Dir is more than bind mount directory. So let me click enter, ls. So now let me get the pwd, sorry, cd bind mount dir ls pwd. Okay, so this is what is my bind mount directory. Let me copy this and I'll put it here. After that we can use that. So our bind mount directory is this. Okay, so now we have image, we have our bind mount directory. So now I want to attach. So in this, at this moment, nothing is there. I'll check it, nothing is there. So I want to make this directory space, I want to map this directory space with the container where lib mysql, so that all the data which is there inside that will be stored here, and if you do any changes here, that will also be reflected there. That's the main point of doing all these things, so that you can keep the data persistence, so that when you kill the container, data will not go away, data will not die. We need data. Without data, world will not exist. It's not, it's an understated, underrated statement, but that's the fact. Okay, now it's time to spin our container. So what I'm gonna say is docker run, and name of the container I'm gonna give is SQL database, or simply SQL DB. And after the SQL DB, so here we have to mention, we'll run it in detached mode, but that's fine. So after that, we have to mention the environment variable, that is root user or super user password. Without that, it's impossible to basically run a SQL database. Okay, so as I was saying, uh, if if you do not mention, if you do not attach a environment variable, the MySQL root password environment variable, we cannot start MySQL container. So if you have a doubt, let's do that without environment variable, and we'll see what's going to happen. So detached mode, and then p port mapping. Then after that, I will map 3030 of host with 3306 of container, and let's do that. Volumes also I'm not going to add at this moment, we'll do that, we'll just for the testing purpose. And the name of the image is q charan mysql version 1. So image has been built, but let's check. Docker, sorry, container has been spun. So let me check docker ps, there is no container. You see, here the container was container was spun here, but here you could not see the container. So let me check docker ps option here. Now you see the container, but it is in exited state. It is in exited state, you can see that. Let me show that again. It is in exited state. Why? Because let's check why. Let's check. So docker logs and SQL database. See, directly they were saying the problem is you need to specify one of the following as an environment variable, either MySQL root password, or MySQL allow empty password, or MySQL random root password. Either of these three you have to mention as environment variable, or else it will never consider, so or else it will never start our database. So that's the reason. Now we will do that with the environment variable as well as with the bind mount. Okay, let me clear the screen. Now we will write it again. Docker run name. Okay, sorry, before that let me delete that. Docker rm sql db. So now docker ps option here, yeah, gone. Now let's build it. Now let's spin it. Docker run name sql db, and we'll put version 1 this time, and option D detached mode, and option E, that is environment variable, that is my MySQL root password, and password I'll give passwd, just passwd, nothing else, or else a password only. It would be much simpler. Okay, then so environment variable password has been given. So now port mapping, same we will take 3030 map with 3306. Then let's do the bind mount now. So for bind mount we have to use volume flag or v flag or volume option, and then let's give what's our bind mount directory. It is /root and bind mount dir. Yes, this is the one, correct? Root bind mount dir. So this should be mapped with I have shown you, I have written, I will show you that. This should be mapped with var container directory, var lib mysql. Okay, I will paste it here for the mapping. Yes, correct, exact. So now let us give the image name. Now all done, all set, let's give the image name qcharan /mysql version 1. So let me execute it and we will see that. Yes, our container has been spun. Now let's do docker ps. Yes, absolutely brilliantly, fantastically, it's running, no issue at all. It's running, it is running, it is running. Okay, it's up, the status is up and running, that's the status. So now, so we're gonna do the checking now. Let's check the directory that we have mapped with container. Let's see the magic. Of course we are inside that directory only, you see that before it was completely empty, if you remember. Now I will do ls. See the magic. See the magic. See the magic. That's what is called bind mount. This is what we call it as a bind mount. So you should see all the data from MySQL, that's container, MySQL container, from the data which is there in var lib MySQL has been copied to this container. Okay, you might have doubt whether it's been copied from there or something in between. This guy might have done something else in between. No, I will show you that also. I will prove you that also. Okay, just give me a second, I'll prove it. So now I'll do docker exec to that container. Docker exec I interactive t terminal tty. Then what's the container name? Container name we gave SQL DBS. Yeah, SQL DB. Then I will use bin bash. I think yes. So bash 4.4. So it has taken bin bash. Now let me do ls. What is there? Okay, pwd first. It's a root directory. So but which directory we want? To which directory we have mapped it? Here it is. We have mapped it to var lib mysql. Whatever is there in this directory should be stored in host machine of root bin bind mount dir. Yes, so let me do cd to that. Now I am inside the container. Okay, cd inside the container. Now let me say enter, and now we will do ls. You see that? exact files, exact files, exact files. The color coding is not there because the container is miniature Ubuntu. The container is miniature Linux distribution, so that's the reason the color coding level of utility is not there in that. So that's why you can see this way only, but the file names remain same. ca.pem, c exactly, even the coding ib exactly it's been copied. Okay, now let me create a touch file 1 to 10.txt. ls, you got 10 files, huh? Now let's exit out of the container and we'll see. Let's do ls. Here is the magic. See, see the magic. Now we are inside the bind mount directory. You can see that, you can compare that. Before it was bash 4.4, but now this is root, because I have exited from the container and I have entered inside I came back to the root directory of our Docker server or Ubuntu server, and inside that you got all the files exactly. So we will do other way around, because I have told you, what did I tell you? What did I tell you? The best use case for bind mount is this. Okay, if if you do any changes to your source code, that can be reflected inside the container, so that it can automatically update it as a feature. Okay, so now we are going to add some Python modules here. So touch py Python modules. So ls, so the files has been added to this. So now let us cross check. Let me do ls one more time. So the files has been the modules that you want to change inside our container, that those modules has been added to our host machine. So now let's enter into the container. Let's enter inside the container and we'll check whether it's been changed or not. So for that, docker exec it and SQL db1 and bin bash. So cd, it's var, let me check that, it's var lib mysql. Yeah, ls, here it is, here it is, features1.python. This is how it will be useful. That's why I was saying the best use case for this is to update the source code, or if you want to add some files from your host machine, some changes from your host machine into the container, so this would be the best use case. So that's the reason the bind mount is always is used for these kind of use cases, to add some changes from host machine to container. So this is one. So now even if I happen to delete this container, I should have this data in my host machine. Let's check this case also. So let me exit out of this and I will say docker ps. So one container is up and running, so I'll stop this container, docker stop sql db1. So I stopped it. So now I will delete this also. So docker rm SQL db1. So now let me do docker ps no container and docker psa no container at all. So now let's check the bind mount dir. So we are here only. Let me check. You see that everything remained everything remained stayed, everything stayed back. So let's check. So we have checked the bind mount there, everything still there. So bind mount is mostly used to inject. That's the main use case of this. So bind mount is mostly used to inject data from host machine to the container, like the code developers code developers are writing. And so while the container is running, so they can do all the code changes in the host machine directory, and they will be reflected in the container when they push it to the when they just it's not pushing also. If you just write it in your host machine directory, which is bind mounted with the directory inside the container, that's it, all will be reflected. Okay, so that's the main use case of it. So we have seen bind mount. Now we will look into volume mount. So the best use case for bind mount, as we have discussed, to update the changes by the developer. But for the volume mount, so if you want to preserve data, if you want to preserve database, for the preserving data purpose, the better option is volumes. So Docker volumes. So for that, let's begin our exercise. Let's get into so before we begin our exercise, let me clean up, let me do the housekeeping. So Docker images, I'll keep the image Docker ps. Okay, anyway, this one, yeah, house was kept cleaned because we have done that exercise now. Okay, so now I'll clear the screen. Ls, you have cd bind mount, you have, yes, everything clear. Yeah, now, so to create a volume mount, so this bind mount experiment is done. Now let's do the volume mount experiment. So I'm going up a little bit. So volume mount experiment. Okay. So now for volume mount, the main use case for that is database, or for preserving data. So this is the main use case of it. But how do we do that? For this, first we have to create a volume. Once volume has been created, you can attach that volume name, or you can map. It's better way of saying is map. You can map that volume name with the container directory or container data directory. So once the mapping is done, and spin the container. So these are the steps we're going to do here. So let's get into the action. So to create a volume, we use Docker volume. Let's type Docker volume and see uses Docker volume and then command. So this is to manage volumes. We have five commands. One is create, to create a volume, then inspect, it display detailed information on one or more volumes, then ls, list volumes, then prune, remove all unused local volumes, rm, remove one or more volumes. Okay, now let me give Docker volume ls. See, these are the volumes has been listed. Let me show the list of ls var lib docker volumes. You see that same, this list and this list same, because it's been created that way. Okay, so docker volume. Now to inspect, docker volume inspect anything one. Okay, we will create our volume and then we'll inspect it. We have some, okay, or else we'll list it docker volume ls, and now we'll go docker volume inspect. I'll take anyone. You see that you got the complete information about that volume. So created at 2023 128, today at 9:22. Driver local, labels null, mount point. Where is the mount point? You see that where lib docker volumes. This is what the mount point in our host machine, in our docker server. That is the mount point. Let me copy the mount point here, so that create a volume, and volumes mount point is this. Okay, this is mount point. Mount point. Okay, and name, this is the name, so we are gonna give our name, options, and scope local. So let's create our first volume. So docker volume, to create the command create. So docker volume create, and name I'm gonna give volume name, I'll say SQL wall. Okay, this is enough, SQL wall or SQL volume, and let me enter. Yes, it's been created, SQL volume. So let us do docker volume ls. You see that last one, and let's inspect that docker volume inspect SQL volume. You see that created just now we have created, and local, and the mount point is this. So I will copy this, and name of that SQL volume. So let's go to cd and let's put this, and we should know cd to, yeah, copy this and paste it here. Now let's see, here is that data. Okay, we have directly entered into that. Now you see that SQL volume, so cd SQL volume data, where data directory, it's completely empty, nothing is there. So our SQL volume directory is completely empty. So now we will map this volume with the containers data directory. So for that we have to spin the container. So let me clear the screen, come to root directory. Now we will do that. So docker run, name of the container SQL DB, that's enough I guess, or wall mount. This is to do the wall mount experiment, so that's the reason. So name is done. Now let's run it in detached mode, then we'll check the environment variable MySQL root password, and I'll give password. That's it. That's the password of it. And then option P, the port mapping 3030 with 3306. Then let's do the volume mapping. So volume mapping, what's the name of our volume? Our volume name is SQL. Did I write here? Nope. I did SQL volume. SQL volume. I hope, or else we'll look into that. So then map this SQL volume to the where. I'll just copy this. This is our mount point, and where is that? Here is, yeah, where lib MySQL. Okay. Then image name. So image name is cube Charan and / MySQL version 1. So done. So let me execute it. That's it. The container has been spun. So now before I check the, or I inspect anything, let's check whether the container is properly running or it got exited. So docker ps, yes, absolutely fine. It's up and running without any issue. So now let's do our activities one by one. So now first, as I told you, it should have stored the data in where lib docker volumes directory. So let us check that. To do that, ls, just a minute, ls where lib docker volumes, you got the this one. So let me move there, where lib docker cd volumes. Now let me get into this SQL. You see that data directory. Here is the magic. Here is the magic. You see that all the files which are there in this directory has been copied. So in the volumes directory, you should find your volume directory with the same name that you have created, that is SQL volume, SQL underscore volume, and inside that we have all the data. So but we just want to cross check whether the SQL container also consists of same data or not. For that, what will we do is we will do docker exec it interactive and terminal. Then container name is SQL db wall mount. Then I have bin bash in that. That's what I'm going to access it, and see we are inside the container. So let me say ls and go to the cd where lib MySQL. You see that? You see this here? Sorry. You see these files here, and you see these files here. Same, exactly same. Now I'm going to create more files and we'll see the magic. So I will do touch file .txt ls. You see 10 files has been added. So let me exit from this location and get into our volumes data. You see that SQL volume, this is the volume that we have created, saying docker volume create of command, and then inside the data. Now let me give ls. You see that file 1 till file 10 all has been reflected in our host machine. So like that, if you consider the similar example, WordPress, whatever you type, whatever blog you write, that all will be immediately the blog, whatever data that will be stored inside the database, all will be copied, all will be reflected inside the host machine. Even if I remove, even if I stop and remove the container, I can still have a data with me. Now again, if I happen to delete this container, the data is still in my host machine in a volume. I can attach to the new container when it gets created. That's simple. Let's do that. Let's do this exercise. That's why I'm saying now this is beneficial. This, the best use case for this is to keep, if you want to have that data, if you want to have a database, okay, that for that it's a best case. If you want to preserve a data or database or data tables, this could be the best case. So let me do docker ps. So docker stop this container, and name of the container is sql, and once it's stopped, let me remove the container, docker rm sql. So now it's been removed. So now what I will do is, let me check that ls, see that the data is still there. So now what we are going to do is, now I can attach the same data. So the data will not go anywhere, because see, I've told you, I gave some example. We want to keep the data and we want to upgrade our application. That's what we want now, right? Yes or no? Yes or no? You only tell me. For example, in the blog example, 15 blocks were there. If you remove the old container, all the blocks will be gone. Okay, then if you create a new container, even that container should have old blocks as well as the new blocks that you write. Yes or no? To do that, this is perfect. This is absolutely perfect. Now I'll show you that. Now file 1, file 2, file 3, these are the additional data that we have created. Now similarly, I'll create 4 more files, touch, and I'll add YAML files. Okay, templates dot YAML files ls. You see that there are a lot of files now in this. So now let's run the container and we will attach this volume. So what's the volume name? So docker volumes, docker volume ls. This is the volume name SQL. Okay, let's run it again. Docker run name and SQL db wall mount wall mnt. Then detached mode option E, MySQL root password, and the password is password. Then option P, then map 3030 port of host with the 3306 port of container. Then let's attach volume. So volume name is SQL, volume name is SQL volume, and map with var lib MySQL. Then image name cube cheren MySQL and tag 1. Correct? Yeah. So let me enter. Yes, it's been built. New container, docker ps. Yes, it's up and running, no problem at all. So now let us enter into the Docker and we'll see how many files has been created, whether the existing data which is inside the volume mount has been attached, has been copied into the uh, container or not. For that I will do docker exec it, and container name is SQL, and then I will use bin bash as usual. So we are inside the container. If you want, we are inside the inside the container. Who am I? Root user, host name, nothing. Okay, that command is not there. So now let us do the pwd and ls. So let's get into the var lib mysql. You see that file 1 till file 10 and templates 1 till 10. Okay, 1 till 10, all templates and all files. You see that? That means the existing blocks also has been copied. So that's the power of volume mount. See, the volume mounts can be useful. That's the reason for the volume mount. The best case is database or for preserving data, and for the bind mount the best use case is to do the changes in the host machine, basically for the developers. If you want to add a piece of code, then for that it would be better. So now we will clean up now we will clean up the containers. Now we'll clean up the docker server. So first let us exit out of this and clear the screen, and docker ps stop this container, docker stop, and after stopping docker, or just for fun we will do small activity before we do the cleanup of this. Okay, the activity is pretty simple. I just want you to enter inside the mysql and give some commands. That's it. Like, anyway, we have deployed a mysql database, we have deployed a mysql and service. So now I just want you to take inside the mysql and use that mysql. So let me do mysql. So there is no mysql this thing, so I'll install apt install mysql. Okay, we will install while running, not now. Apt update. So now let me do the docker inspect of the container sql db wall mount. So just copy this ip 172.17. this is network, and 02 is host. This is the gateway for this host. So host gateway's address is 0.1, and our container's address is 0.2. Anyway, so now let's ping the container. Ping and paste it. Yes, it's successfully running. You can see that 64 byte from this. It's sending the packet, it's receiving the packet icmpseq1, and milliseconds, within milliseconds it's able to take that. Okay, so now as we have, let me come out of this. So now let's open mysql. Let's open the mysql. Let's access the mysql inside the container. For that I will type mysql and then option h and container address, that's IP address, containers IP address. Okay, I don't get it. Oh, something else has been copied, na? That's the reason. Okay, no problem. These are all of those. Okay, let me clear the screen. CD root. Yeah, this is fine. Best place to be. Now I'll give MySQL. Before that, let me get the Docker inspect SQL DB Walmart. I want this IP first. Let me copy this IP. This is just for fun. We are not doing so. Our main important exercise has been done in this case. Let me copy this IP here. Okay. So now let's do MySQL access. MySQL option H. Then after that we're gonna use give the space and get me the IP. Okay, here it is. And paste it here. Sorry. Then after that I'll say root user space U, that's a user. U option is for the user. Then I want to go with the root user and the password that I have mentioned, a P option for the password, and password mine is password itself. Okay, all done. Let me click enter. So it's unable to get it because MySQL warning using a password on the command line interface. Okay, we have entered. So we are inside the MySQL. We are inside the container now. So now let's what it's saying. Warning, using a password on the command line interface can be insecure. So welcome to the MySQL monitor. Congrats. So welcome to the MySQL monitor. Command ends with /G. Your MySQL connection ID is 8. Okay, our connection ID is 8 and server version is 8.0.32 and MySQL community server is GPL. Okay, and one more thing I just want to tell you before that you should install MySQL inside your server. Okay, to do this, because we are giving MySQL command na here. To give MySQL command, you should have a MySQL. So you have to say apt install MySQL this version 8.0.32. So I'll copy that. Wait, I will paste it here. You do that. Apt install MySQL and then version 8.0.32. So you'll find that proper version. So you install that, and after that you execute this command. So I'll copy this also so that you can see that clearly. Copy it. I'll paste it here. Yeah, and this is anyway IP has to be placed there. So now let me check. So Oracle is a registered trademark of Oracle Corporation and or its affiliates. Other names may be trademarks of their respective owners. So for help, you can go for this. If you give a /C to clear the current input statement. So let me go for the help, /help. So I can see some of the commands here. So first I will type just shortcuts also there, but I'll type help. So if you type help, you will get the help. Okay, and if you type clear, it will clear the screen, and if you type connect, it's gonna reconnect to the server So optional arguments are DB and host. You have to give DB database. Then you see that connection ID is 9, but there is no database is mentioned. So that's the reason. Then if you click exit, we're going to exit out of the MySQL server. See, it said bye and we came out of the MySQL server. So let me execute that one more time to enter inside that. Yeah, now I am again inside. I'll say help. So then delimiter, set statement delimiter, then edit command is to create an editor, to make an editor. You see that now you can give your MySQL schema, a SQL schema, create this, from this bring that, so from this select all and do something. So these kind of SQL all everything you can give from variable name and bring all and do something. So this kind of, for this kind of activities it will be useful to edit. Then you go for go, so send command to MySQL server. If you click on go, okay, let me clear the screen. It's still under editing. Yeah, now we came out. Now when I say go, so we have to specify a query so that it will connect with MySQL. So help, then note and pager, a print a current command, prompt, change your MySQL prompt, then quit to quit MySQL, and source, let me give status. This is what the status of the server. So MySQL and version 8.0.32 and Ubuntu 20.041 for Linux. So connect ID is 10. Current database, no database has been created, but the current user is a root user at this IP, and SSL and std out current pager. So server version is this. Okay, this is the correct proper version. You use this while installing. Yeah, here. Okay, and protocol version 10. Connection, this is the connection 172. This is container IP via TCP/IP protocol that we have discussed in networking module. Then server character is a character set DB client con, all are this, and TCP port is this, we have mentioned that, and hexadecimal uptime 12 minutes before it started. So remaining all other information you will get it from here. Then let me give system. So system is shell command. Then T, use must be followed by database. We should have one database to use that command, and help. So that's how you can enter inside a container and using a MySQL application inside your host server. You can basically do whatever you want inside that container, maybe creating a database and creating data tables and running the SQL schema, running the queries, whatever you want, you can do everything. So let me come out of this, exit, let me exit it, and let me come back to my, yeah. So here we have seen two examples, we have specifically seen two examples. So we have seen bind mounts as well as volume mounts, and what are their best use cases. For volume mount, the best use case is database or preserving data, whereas for the bind mount, to do the changes in source code of application, or this is best fit for the developers if you want to update or upgrade your source code in the container. So bind mount would be the best way of doing. So after that we have run some queries in MySQL container also. So now it's finally we have come to the cleanup procedure. So let me clean up everything and we'll close this, we'll wrap up this exercise. So again get back to this, clear the screen, docker ps, nothing is there. So docker ps1 container is running. So now let me stop this container, docker stop, and container name is SQL db volume mount. Now let me remove this container, docker rm SQL db volume mount. So now it's been done. Now let me check the images, how many images we have. We have only one image. Now let me remove that image also, that's cube chair. And yes, docker images. Let me cross check one more time to list out nothing, no images, no containers, it's all done. The machine has been cleaned, so house has been kept. That's it in this exercise. Now we will see more ways to make a data persistent. So let's write what are the ways that we have seen so far first, and then we will move ahead. So what we have to get here is our sticky note. So now let me, yeah, yes, we have done the data persistence. Yeah, persistent data is done. So now let me close this one. Yeah, now data persistence. So one is volume mounts to bind mounts, 3 data containers, and 4 NFS. Okay, so first two we have seen with example. So now we are gonna see the third one, the data containers. If you use volumes a lot on a host, managing the containers startup can get tricky. So you may also want the data to be managed by Docker exclusively and not be generally accessible on the host. So one way to manage these things more cleanly is to use the data only container design pattern. So in this case, our problem statement is we want to use an external volume within a container, but you only want Docker to access the files. So how can we provide a solution? So we have to start up a data container and use the volumes from flag. Volumes, that's a long option, and from another option. So we'll merge both, and volumes from flag when running other containers. So let's take this example. So this is our host 1. Let's call it as a host 1. And this host 1, there are 3 containers are spinning. One is container A, container B, container C. And the host is running 3 containers, and each pointed at the hosts where DB tables. It's a bind mount. Okay, you see that bind mount. So we have to use volume option, and then where db table, and db is the directory inside the container where the data stores or database stores. Okay, so now each container A, container B, container C of database of The container A internal directory DB is attached with var DB tables, and container B DB directory internal directory has been attached with the var DB tables, and container C internal directory DB has been attached with the var DB tables. Okay, so that's the if this is the case, so what's gonna happen? So each container has mounted the directory separately. So if the location of the folder changes or the mount needs to be moved, each container has to be reconfigured. Other than that, there won't be any issue, because uh, based on each directory, so all the data will be saved. Container A's, container B's, container C's, all the data will be saved in this directory. But the issue here is, if the location of the folder changes or the mount needs the bind mount that we have mentioned, that is forward slash var forward slash db forward slash tables, if that bind mount needs to be moved, each container has to be reconfigured again. It's a huge work. So do we have any solution to this? Yes, do we have? Yes, we will see that. That's what is our data container. So let's look into that. Host 2. So we have taken host 2. This is a blue machine. Host 1 is a pink machine. Now we will enter into host 2, a blue machine. So blue machine consists of again 3 containers. The host 2 is running 4 containers. In this we will take 3 containers only. So the 3 containers from the previous, so basically total it will run 4 containers, out of which 3 containers are running services or running an application. Okay, what is one container another container is doing, that we are going to discuss. Okay, the 3 containers from the previous host, that same similar kind of containers, so containers A, containers B and container C are running with a different kind of command now. Now the command that we are going to give is volumes option from flag here. Okay. Whereas here we gave just V option, small v, that's a short v, short option. And then we have mounted the bind mount location with the database location of the container. But here we are using volumes option and from. Let's do that. But this is what initial one. Okay, similar to this. So figure shows the, now the problem here, we know that the problem with this everybody knows. Similar thing, if the location of the folder changes or the mount needs to be moved, each container has to be configured. So now how to solve this? The solution is this. So the data container. So this command volume option and bind mount will change to this volume from DC, the data container. The name of the data container that we have given is DC. So I'll animate it one more time. From this option of bind mount, connecting all containers together with one bind mount, we can do this using this command. Okay, so figure shows the structure of data container pattern and explains how it works. The key thing to note is that in the second host, in host number 2, the containers don't need to know where the data is located on disk. So all they need to know is the name of the data container and they're good to go. So this can make the operation containers more portable. So another benefit of this approach over the straightforward mapping of host directories is that access to these files is managed by Docker, so which means that it's less likely that a non-Docker process will affect the contents. So one more thing, the most important point is the data only containers. The data only container doesn't need to run. A common source of confusion is whether the data only container needs to run. It doesn't. It merely needs to exist to have been run on the host and not deleted. So the single data container mounts the host's volume, creating a single point of responsibility for data mounts on the host. So the most important aspect is the data container doesn't need to run, it needs to exist. What does it mean? So let's take container A is a SQL database, container B is Postgres, and container C is some Nginx, some application, an application based server service. Now once you spin these containers, this container will spin throughout its life until you stop it and delete it. Whereas a data container, after spinning the container, it will go to the exit state. It doesn't need to be run or it doesn't need to be spin forever. It needs to exist like that in an exited condition. That's it. So using this data container, we are benefiting such a case if the location of the folder changes or the mount needs to be moved, each container doesn't have to be configured. So far for the data persistence, we have seen three methods: volume mounts, bind mounts, data containers. So one more thing that's left is sharing data over NFS. Sharing data over NFS. So in a large company, it's highly likely that there are NFS shared directories already in use. NFS is a well proven option for serving files out of a central location. For Docker to get traction, it's usually fairly important to be able to get access to these shared files. Docker doesn't support NFS out of the box, and installing an NFS client on every container so you can mount the remote folders. So remote folders isn't considered a best practice. So instead that the suggested approach is to have one container acts as a translator from NFS to a more Docker friendly concept, volumes. Here for us the problem statement is we want a seamless access to a remote file system over NFS. So the solution: use an infrastructure data container to broker this access. So let's look into that. This is our Docker host machine. Inside that we have hosted and spun Docker application container 1 and Docker application container 2 and Docker NFS client container, and so total we have hosted 4 containers. Okay, so Docker application container 1, 2, 3 and a Docker NFS client container. We'll see how this works. Done. Now this is now it's time to bind mount the two containers. How do you bind mount? The NFS server exposes the internal directory as the /export folder, which is bind mounted on the host. Okay, let me show that. This is our NFS server. This is our NFS server. This is our Docker server or Docker host. And here, this NFS server has a lot of directories inside that, out of which /export folder or export directory, which should be bind mounted with the Docker client. How do you do that? It's pretty simple. It's a normal bind mount. But here you have to mention the server information also. You mention the server information and then that directory, and that should be bind mounted with the /mnt directory of the Docker NFS client container, whereas all other containers will be will be connected with the Docker NFS client container. You see that? Yes, that's how it's bind mounted. So infrastructure container mounts the NFS mounted /mounted directory as a volume. Now the Docker host then mounts the folder using the NFS protocol to its /mnt directory. Then a so-called infrastructure container is created which binds the mount folder. So an infrastructure container will be created in the end that binds the mount folder. So imagine that you want to share the contents of your hosts, that is here hosts /opt test db folder which contains the mybigdatabase.db. MyBigDB is one database. That database you want to share. So as a root, install the NFS server and create an export directory with open permissions. That's it. You install apt get install NFS kernel server, then make their /export, then give the permissions chmod 777, that is owner, group and others, all are 777, all permissions give to the export directory. Then once that is done, now bind mounts the db directory to your export directory using this. Bind mount your db directory with export directory. Then now you should be able to see the contents of the opt test db directory in export, the /export directory. So here you can see that example. So you need to require the IP of that server also, NFS server. So that will also be included while you are doing while you are giving these commissions. This is how a sharing data over NFS works, but we'll look into more. So here for safety we are mounting read only here, but you can't mount a read write by replacing, but you can also mount read write by replacing arrow with rw. So it's just an example here, you can go through it. You see that how do you mount an NFS server. Okay, so for that the command that we're going to use is mount option T, that's for tag and NFS, you're tagging it. Then after that you can see that here 127.0.0.1, this is the directory, the IP of the host machine of the NFS, that's NFS server, and then that has been mapped with / export or MNT. Then export FS option A, then finally you start the service, that NFS kernel service, you start that. Then once that is done, you are ready to run your infrastructure container. Then another infrastructure container will be spun. For that you have to say docker run option T is again that, and is interactive, and name tag, you are giving the name to the container. Okay, so then your container will be spinning. So then after that you can use naming convention for operational efficiency and all those things you can do. So the pattern of a shared resource mounted with privileged access centrally for user used by others in multiple containers is a powerful one that can be development, that can make development workflows much simpler. So not a substitute for security. Remember that this technique only provides a security through obscurity. As you will see later in our Docker sessions, as we move across our Docker module, we'll see more. So let's see whether we have done all four. Yes. So for data persistence, volume mounts, bind mounts, data containers, and final one is NFS. So all done. Now let's look into inspecting the images and containers. Although the Docker commands give you access to information about images and containers, sometimes you want to know more about the internal metadata of these Docker objects. So let's look into one use case of inspect. So the problem statement for us here is you can inspect. So we have to inspect images and containers by name or ID. You can do either image and container. Obviously, their metadata will differ. For example, a container will have runtime fields such as state, that the image will lack an image because an image has no state. We are going to do that. We are going to do inspection of image as well as inspection of container. So in this case so the next thing is, for us in this case the problem statement is we want to find out a container's IP address on our host. Okay, to do this we need to do this we need to use the docker inspect command with the specific. Okay, so now let's jump into that and we'll see. But before we do the practical demonstration of inspection, a Docker inspection, I will just see how does the output of this inspect command looks like. The Docker inspect command gives you access to Docker's internal metadata in JSON format. We have discussed what is JSON. If you have no clue about JSON format, you watch my previous videos. In that I have explained Python dictionary, JSON format, and even YAML format practical demonstration. I request you to, I urge you to go back and watch that. And now we are talking about raw inspect output of an image. So that we're going to do that now. So when you give an inspect command, it throws out an internal metadata in JSON format. So this produces a lot of output. So only a brief snippet of image that you can see here on screen. This is one just, it is a small part of that JSON format, that output of inspect command. Okay, so either you can inspect images and also containers. So if you give a container name, if you want to get an IP address of a container name, you can give even a container. Okay, so let's look into this one by one. First we will begin with okay, so let's do our first exercise here. So that's inspecting the images and containers. We'll begin with uh, Nginx or MySQL or whichever. Let me, so okay, it's gone out. Sudo I, let me clear the screen first, and let's do inspection. So before that, let me get into my Docker Hub. So repositories. So I have Cube, Nginx, MySQL, WordPress. We'll begin with the Nginx. Okay. So click on Nginx, click on see all, then copy the Docker pull command. Okay. Now I'm getting back. So I'll paste it, that command. So Docker pull and name of the image with tag. So the image is being pulled at this moment. So the image has been pulled. So Docker images, and you see that this is your image. So now I want to run this. The problem here is I want to run this, but I do not know I do not know the port where this application is running inside the container. How would I know that? Because I have to map it now. I have to map the host port with the container port. How can I get to know? Because I do not have a Docker file. I have only Docker image. How can I get to know? That's my question. You answer me, guys. So the way is doing Docker inspect. So Docker inspect image name. That's it. Let me click on, and you're gonna exposed to the metadata of that image. So let's begin from the starting point of the output of Docker inspect, and we will scroll down slowly. Yeah, here it is. So ID of the image, then tag, it is this, then repo digest, this from Cube Charan, this is from my GitHub, and parent date created and container if it is run. So then this is what, this is exposed to port 80 and with TCP. So this is what we want. So I'll just copy this, and let me come to the, so example, and this one is inspection. So what we want, port exposed application port where it is running. So that is this. Okay, the exposed port is this 80. So now we got our port. Let's take this port, and now let's get back to our work. So before we run it, you can see that this is terminal TTY, it's false, and Other things, path, you can find the path. Nginx version, you can see. These are environment variable when you call. Okay, we'll do that. I'll show you this again when we do exec. So, but these are environment variable. When you use this environment variable, we can get it respective value. And command, when you spin your container, this is going to be executed. You can see that cmd nginx and daemon off. So nginx will be started. Then volumes, null, workdir, null, entry point is docker entry point dot sh. And few more objects that we can find here is on build, null, labels, it's maintainer, yep, and stop signal sequit. So additional information, architecture is AMD 64, OS is Linux, virtual size, graph driver, more information, overlay, work there, and so all the layers are mentioned. 3 plus 3, 6 layers, and last time tag time is this one. So that's what the complete metadata of the image. So from here what we want is port, and the port has been successfully copied here. You can see that this is what the port 80. So now we got the port 80. So now let's spin our container. So docker run, name of the container is load balancer, detached mode, and port mapping 8080 with 80. This is 8080 is the host port and 80 is the container port. Then let's copy the name of the container and we will, and it's v1 tag. Rest all done. So now let us spin a container. So unable to find this image locally. That's okay. So let me cross check. Yeah, nginx v1 fine. Docker run detached mode charen nginx and v1 tag. Okay, this new. Oh, that's fine. That's fine. I got it. I got the problem. This is small v. Yes, it's done. Clear the screen and let's do docker ps, and here is your container, that is load balancer. So now let's access this application first, and we will do the remaining things. For that, let me get into, so yeah, instance, copy the IP, paste it here, and host port 8080, and this is your application up and running successfully. Okay, so now let us get back to the server and let's inspect the container. Docker inspect container name is load balancer. Oh, okay. Docker inspect load balancer. Yes, this is the data that you get when you inspect a container. This is completely different. This is all about what we have done with our container, how we have spun our container. Let's look into this metadata, objects of this JSON from the beginning. Yes, it's where it is at the beginning. It's too much. There are a lot of data, lot of data. Yeah, here it is. So it begins with ID, then path. This is Docker entry point. Docker entry point is the beginning. Then auth. This is what it will execute when you spin a container. The most important thing, state. The state object will be there, whereas in image you won't get it. When you inspect an image, this state object won't be there, whereas inside a container you'll find the state object. So status, running, PID, that's a process ID, and started at and finished at. So image ID is clearly mentioned, and a path. So most important thing, port binding. Network mode is default, and the port binding is another one which is very important for us. So how this is 80 TCP that belongs to container, whereas this is mapped with the host port of 8080. Got it? You see that? 80 and 80 of the host has been mapped with 80 port of the container. So this kind of information we can cross check. By mistake, after executing, after spinning the container, you forgot what port mapping you have done. You just come here and you can check. Of course, if you do Docker paste fill, you'll get it. But if you want it clearly, you can come here and check. And then there is more information about a lot of parameters are mentioned here, so you can go through the each parameter in depth. It's mentioned a lot of things, and mask paths, proc, core keys, and here you'll have a work there with the overlay, and here you see config, the host name, this is name of the container, domain name we haven't attached, username no, and exposed port as usual we have discussed earlier, it is 80 TCP. Then here we have environment variable that we are going to see soon, and command cmd, this is what will be executed when you spin a container, and image name you can see that kubechurn nginx small v1, volumes nothing, null, and here the network settings. Here you will find a clear cut network settings. Complete the proper port bindings. If you bind this port with many host ports, all will be shown here. And finally here you will find that gateway. This is gateway. This is very important. A network, basically this is network bridge. This is a network object. Network, yeah, see network settings. the bridge will be there, and the bridge, and then you'll have a gateway to this container, and the gateway will be connected through the gateway is 172.17. This is the network, and this is host name, host octets. These are network octets, these are host octets. So both 172.17 and 172.17 gateway and IP address of your container is in same network, and this is 01 is the host identification, 02 is the host identification of our container. So whatever that you connect from, let me show that. So we use 65 130 to 34. When you call this, so it will go to this 172.17.01 IP, and as a gateway it will be used, and then this will connect with 172.17.0.2, and finally we are able to access our application. That's how it works. And you can see the endpoint, network ID, gateway, and all. So now what will we do is we'll ping this. I'll ping we'll ping our container, and we'll see the data transfer. Nothing much. It's okay. Sudo I, and clear the screen. Ping. It is, yeah, you see that we have pinged this IP address, and this belongs to container. So 56 bytes of data, and this is the packets has been moving around ICMP sequence 1 TTL time milliseconds. So basically it is working properly, it is communicating well, it is continuously uh, transferring the data packets. So that's how we can use our inspect command of Docker with image as well as container. So this technique can be useful for automation, as the interface is likely to be more stable than other Docker commands. So we have used the ping. So the ping only accepts one IP address. We had to pass an additional argument if you want to uh, basically do more. So in that case you have to attach an additional argument called xargs, telling it to run the command for an individual line. Okay, so let's so we have seen Docker inspect. So in Docker inspect, this is our Docker inspect command. We'll just go through the theory one more time. We have done the practical demonstration, but I would like to explain it one more time so that it would be damn clear for you. So then here you will find the ID of the Docker item you want to inspect, and here if you can use a format flag. The format flag, this uses Go templates to format the output. So here the IP address field is taken from the network settings field in the inspect output. Okay, and finally to get IPs of running containers and ping each in turn, so we use docker ps-q, and then you pipe it with the xargs docker inspect, and then here you're bringing that IP address, and then we are pinging that IP address. You can see that. So the first line gets the container IDs of all running containers. Then it runs the inspect command against all container IDs to get their IP addresses. And the last one, xargs pipe, xargs L option 1 ping C1 option takes the each IP address and runs ping against each in turn. Okay, I hope you got that. I just want, these are advanced commands that I have attached. If you want to explore more, you can use these commands directly from here as it is on your laptop and on your server, and you can explore more. But by the time, what will we do is I will get into my Docker server and we'll do few more demonstration. Okay, it's still up. Yeah, you see that? 220 packets transmitted, 220 received, 0 percentage packet loss, and time is this much of milliseconds, and RTT minimum average median. Okay, so minimum is 0.47, average is 0.054, and maximum is 0.062. Fantastic. Whereas deviation is 0.02. Let's clear the screen and let's bring up one more image. So Docker pull, let me get into my Docker hub for that. Where is that? Yeah, here, repositories, and scroll down a bit, get into MySQL. No, this time we're gonna do uh, one more thing. Yeah, resume. Hello. Yeah, multi-stage app image. So let me click on see all and copy this and pull the image with tag version 1. That's a v1. So it's pulling from kubechern multi-stage app image has been pulling, all the layers has been pulled. Now let's check Docker images. It's here it is. So but for me again the same issue. I do not know which port the application has been exposed inside the container. Then how would I know that? Answer me guys. How would I know that? So we have to use inspect. Docker inspect image name. Yes, that's it. So directly we have gone through the each object of JSON file. So that's the reason. Let's simply get into the main part. It is again exposed port is 8080 TCP. So now let's get into that, and meanwhile we can see one more. You can see a lot of environment variables. You see path, Java home, lang language, Java version, Catalina home, Tomcat native, GPG keys. Oh, you have GPG keys and then Tomcat and lot of environment variable. All we're gonna explore soon. Don't worry. So now let's. So we got that. It is a second container. This one is Nginx, and the third one is multi-stage. So let me copy this here. Yes. Okay. I copied the wrong one, but the port exposed port is 8080. Let me. Oh, there are a lot of variables. Environment variables. Yeah, here it is. Exposed port. Copy and put it here. So now let's run our clear the screen, Docker run name option. This is Wipro app and detached mode, and port mapping I'm gonna do with I think, let me cross check Nginx in which port. This is 8080, so I'm gonna do 8090 with our container port is 8080, and name of the image okay. So let me copy this because I do not know. I know, but exactly I don't remember. So let me give name of the image. We'll just copy the name of the image directly from here itself. Okay. So let me paste it here and now copy this name of the image and give a space. Yes. Okay. Got it. Version 1 done. Version 1, it is done. Version 1, it is done. So Docker PS, you see that just up 8 seconds ago, that the name is Wipro app, and here is that, and port is 8090 is mapped with 8080. Now let's get into that. Let's access that. Let me copy this. I'll keep that same because that's another container which is running. Now I will change it to 90 and see the magic, magic, magic. That's it. You see that? So 8080, one container is spinning and the app is up and running. And 8090, another container is spinning, the app is up and running. So now what will we do is let's get into the container. Let's inspect the container. So Docker inspect, the name of the container is Wipro app. You see that? You got it? Now you can see the MAC. This is the MAC address. That is a physical address of the device. Then you see that? You see that? Gateway remains same, 172.17.0.1, because this is containers gateway. But at this moment, how many containers we have inside our Docker server? We have two containers. So one container took the IP address of 172.17.0.2. Another took 172.17.0.3. So with this, the networking concept should also be pretty clear for you. That's the reason I'm demonstrating this. Okay, so you have a gateway and these other containers will get connected through the gateway. So the gateway is common for both the containers. I'll show that also. Don't worry. Okay, and this is our. Then now let's scroll up a bit and we'll see the bridge network we have seen, the gateway we have seen, and IP address we have seen. And here you could see that host port is 8090 and container port is 8080. The proper binding or mapping has been done. So rest all is as usual, image name and volumes is null, working there. And here you can see the catalina.sh run. This is a command, like when you spin a container, this should be executed. And here you can see your environment variables. Rest all same. So let me scroll down completely. And this part, let's copy this. This three, this belongs to Wipro app. I'll paste it here. And now let's do the Docker inspect of another container, that is app. Okay. Docker PS. It is a load balancer. Sorry. Docker inspect load balancer. Let me copy this too so that I can prove it. So I copied this too and I'll paste it here too. Here too. Yep. You see that? Let me scroll up a bit. Yes. So this is Nginx container with gateway and IP. IP of the container is this 172.17.02 and gateway remains same, and this one is a Wipro app and gateway is 172.17.01, whereas IP address of container is 172.0.3. Two things I just want to prove here. The first point here is the first two credentials. So based on 16 IPRIX, basically this is called subnet masking. Subnet masking, what is that? Subnet masking. So here in subnet masking it is 16, that says 8 plus 8, the initial 16, and then 8 plus 8, the other 16. Though see here in this case the first 16 bits represent network and remaining 16 or 2 octets represent host. So it's very clear 172.17 is the network address of all these three, container 1 and gateway and container 2, whereas the second, the last two octets are representing the host name. So if you remember that, we have discussed all these concepts. So now 172.17 is common for all, whereas 01 is gateway, 02 is container 1, and 03 is container 2, that is Wipro app. Now how do you route it to other two containers? Through the gateway, through the bridge. So the 172.17.01 is a gateway. So that receives a command from the public IP. You see, this is our public IP. Let me copy this. When you call that public IP with the port, let me put it here. Yeah, with the port ID, so that a request will reach to gateway first, and then gateway will route it to public IP of the container, depends upon whether it is 03 or 02. So that's how it works. Now let's ping to contain that's Wipro app container IP. Let me copy this and let's ping it. And let's see the packets of data. So it's going on 64 bytes. Good amount of packets has been transmitting. Let me close it and see the, so total 12 packets. You see that 12, 4, 4 and 4. So 12 packets has been transmitted. So 12 received, 0% packet loss, and time is this, and these are the statistics of our packet transmission. So with this we have clearly understood the purpose of Docker inspect command with nice examples. So we have seen inspection of image, inspection of container, and now we are going to do direct action. Direct action? What is that? Nothing. Direct action, execute commands on your container using exec. So let's look into that history of exec command. So in the early days of Docker, many users added SSH servers to their images so that they could access them with a shell from outside. This was frowned upon by Docker as it treated the container as a VM and added a process overhead to a system that should not need it. Many of the developers and operational engineers has objected that once it started, there was no easy way to get into a container. As a result, Docker introduced the exec command, which was a much neater solution to the problem of affecting and inspecting the internals of containers once started. So it's this command we're gonna discuss in this slide. So the problem statement here is we want to perform commands to a running commands on a running container. Is it possible? As it is possible, it was made possible by Docker using exec command. So we will start a container. For that, we'll start a container in the background with option D, that is detached mode, and tell it to sleep forever. Do nothing. We will name this command as a sleeper command. So run a container to run Docker exec commands on. So first you run your container. Once your container is up and running, then we can use this basic we can use Docker exec to access the containers bash. Okay, so here, now that after starting the container, we will perform various actions on it using Docker exec command. So we'll start a container in the background and tell it to sleep forever using the commands. Then we'll do basic daemon in interactive. Okay, and after that, we are going to do attach more commands. The next exercise we are going to do is Docker exec sleeper echo hello host from container. Sleeper is the name of the container, and we are saying you enter inside the sleeper container, and inside that you print hello host from container. So here in this case, what happens is, note that the structure of this command is very similar to the Docker run command, but instead of the ID of an image, we give the ID of a running container, and the echo command refers to the echo binary within the container, not outside. It is within the container, not outside. So the daemon mode runs the command in the background. You won't see the output in your terminal. So this might be useful for regular housekeeping tasks where you want to fire the command and forget, such as cleaning up log files as in the following listing. You see that if you want to delete log files older than a week on a container, it's very difficult to handle those things. So then we'll use Docker exec option D, detached mode, and sleeper. So here what we're going to do is this, the D flag runs the command as a daemon in the background. Okay, in the background, it will run this as a daemon in the background, and it will do the required when it is need to be done. So it removes all the files that are unchanged in the last 7 days, and that end with a log. Okay, whichever file that ends with the log which hasn't been touched for the last 7 days will be removed using this. You see that the time that we have given it all, find and then see time option and 7 days, and the name. If any file that starts with a log, that contains a log in it, should be removed if it is not changed inside the container. So returns immediately regardless of how long it will take to complete, because it's a continuous it runs on background. Okay, so finally, we have the interactive mode that we're going to do. This allows you to run whatever commands you like from within the container. To enable this, you will usually want to specify the shell to run interactively, which in the following code as bash. You see Docker exec it, interactive key is TTY, that's a terminal, sleeper is the container name, and bin bash is the shell that we want to use it, and we are going to do it. Now let's get into our Docker server to demonstrate or to do direct action into the containers. Yeah. So let me do Docker images. Yes, absolutely fine. So now we are gonna do this exercise using MySQL. But before that, what we're gonna do is let's also do exec into the Nginx and our Wipro app. So Docker PS. So two are running. One is Wipro app container. Other one is load balancer container at 8080 and 8090. Let's look into that. 8080 is Nginx, 8090 is our Wipro app. Okay. So let's do the exec. Docker exec. What I'm gonna do is let's get into the slide. It is echo hello host from the container. Okay, Docker exec, it's a load balancer, and echo, sorry, yeah, because just printed, it just echoed the empty space, but I'll say echo hello run from the load balancer container. Here it is. Here it is. Hello, Charan from the load balancer container. This is from load balancer, not from our machine. Okay. And similarly, we'll exec from the Nginx container. Nginx, sorry, Wipro app container. That's Wipro app. And it's Wipro app. The name of the container is Wipro app. And here it is. Hey, Charan from the Wipro app container. You could see that. I think you can see that. So now it's time for the direct action into MySQL. So clear the screen for that and get into my Docker Hub and bring it up the respective image. So Docker image, I'll go with the MySQL and scroll down a bit and find out the tag v1 and copy it and paste it in our Docker server and execute it, and within seconds you would see Docker MySQL image. Here it is. So let me say Docker images, and here Docker cube Charan MySQL and version 1, that's the tag. Yes, nice. So now let me let me know what is the port I should map it. That's very important. For that, I'm gonna do Docker inspect of image. That's cube Charan MySQL version 1, and let's get into that. Last tag time is this, and there are plenty of I think maybe too many layers in it, and overlay and loader OS Linux varlib volumes, varlib MySQL volumes and working there. So image name and command is MySQL D. Then we have our environment variables. So that we're gonna do, we're gonna execute environment variable of each. And Docker version 20.10.2.12 and volumes and CMD MySQL D 8.0. Here it is. Here it is. Exposed ports. So the this service in this MySQL database has been exposed to 3306 port inside the container. So I am gonna copy this. Anyway, anyone. So both of anyone is works. Anyone will work. So copy that and go to your. Okay. This is direct action example. Okay. Brilliant. So MySQL is the one which you have taken, and here are the ports, and now it's time to run the container. So Docker run name db, and what we have is after that, after db, we'll put it in detached mode, and then environment variable, that is, sorry, MySQL root and password. So I would take it as passwd is our password, and so port mapping as usual. So I'll put 3030 of the host with what's that, 3306. Okay, 3306, 3306. Then we will give the image tag, so it's cube and MySQL version 1. So let's cross check and let's execute. Docker run name option, db is name, and detached mode environment variable MySQL root password, passwd is the password, p is the port mapping from 3030 of 3030 of host machine with the 3306 of the container, and then name of the image. Let me execute it. Here it is. So your image, your container is spinning up and running. So Docker ps. Okay, Docker PSA, it is in exited state. Let us check what's the problem. When you, to troubleshoot also we use inspect again. Docker inspect and db. So this is okay. No, sorry. We'll use logs to get the actual clarity. Yeah, the problem with this Docker logs DB entry point script for MySQL server started switching to dedicated user MySQL entry point script for MySQL server started error, database is uninitialized, and password option is not specified. Not specified. What? Let me cross check. Okay. MySQL root. So Docker run name option, then db detached mode environment variable, and MySQL capital root, and then sorry, that's underscore, and so this time I'm gonna spin a db1. Okay, that's the issue there. Okay, port mapping 3030. Okay, rest all fine. Let's do that. So Docker ps, here it is, up and running. Yeah, you see that, and it's db1, it's db1. So it's time for us to do the docker inspect to the container. It's db1, and you see that. So total we have one gateway and three containers are up and running. They are 2, 3, 4. See the proper networking. You can see the networking here itself. Here itself, the first two octets represents identifies a network, and second two identifies the host, and that's pretty clear. That's fantastic way of learning networking. This is the best practical demonstration of networking and gateway bridge and everything, all such concepts. Anyway, let me copy this one here. And I'll ping this one. I'll ping it and I'll see what's the status, whether it is sending and receiving the packets or not. Yes, pretty well. It's working 64 bytes. Let me close it. Yeah, 11 packets has been transmitted, 11 received, absolutely fine. So now let's do some magic. So docker exec, and here it is. I'm gonna use docker exec, and name of the, what's that, it's name of the container. Yeah, name of the container is db1. Then I would say echo, yes, send me some data here. Store my data in your database and return when I want. Let's see what's going to happen. Here it is. Hey, store my data in your database and return when I want. Nice, na? Okay. Now, what we are gonna do is we are gonna execute, and we are gonna operate MySQL schema, MySQL server of this container from our host server, from our host machine, or from our Docker server. So for that, we need to install a Docker, install MySQL. Okay, for that, we have to bring up apt search, and pattern is MySQL. Done. Huge amount of stuff has come. G. Okay, this is huge. It is Tsung, Test Kitchen, Tango, Simpa, SQLine, SQL Gray, and it's lot Ruby SQL, Ruby Amazon EC2, RT4 DB MySQL. Lot. There are a lot of packages which are with that pattern, and Python 3 AIO MySQL, and Python Novak client and doc, and PostgreSQL, PHP 7.4 MySQL. So lot of, lot of, lot. MySQL client 8.4. I'm gonna go with this. So there are few more. It's not few, it's a huge. But still, I'm gonna copy this, and we are gonna install this. Sorry. So it's apt install and package name and option y. Here it is, it's getting installed. So once it has been installed, okay, it's done, it's been installed. So now I can use this MySQL, basically MySQL, to connect to the local MySQL server through socket var run MySQL d.sock. That we're gonna do. For that, I will give command MySQL command, and attached with option H, that's a host, and the host which is hosting the container is okay. For that, I have to bring up, I have to do docker inspect again to the container. For that, docker inspect, I remember, I think 172.0 dot something. Okay, once a docker inspect, and then db2. Okay, yeah, this is what, wow, okay, 172.17.0.4. Copy this. So now let's do that. MySQL option H, and database host name, or that's our container IP, and I'll go as a root user, and I'll give the secret pass that I think I have given, pass WD, correct? Let me enter. Yes, we are inside the container, and we can do any operations inside the container. It's like working on your database. So now I'll give /h, and you see different commands that you can use to execute inside that. And let's begin with connect. You can use a connect to connect with the database specifically for that connect, and then you have to mention the database name db1. So there is no database such as db1 or db2 or db3. First you have to create a database, and then see, and then you can connect with the database. Okay, yeah. So similarly you can give use and char set and a lot. So print, yes, this is what it prints, that database information. If you have, it's like show databases. Then we have no query, so you have to mention the query specified, and then rehash source status system. So a lot of commands, and you can do, basically you can create your database, and you can create your schema. You can work on that. You can pull the data, push the data. You can create, and you can select all the queries that are connected with SQL can be given and can work on it. So let me get out of this. Yeah, say exit. Yes, it's saying bye. That means we have to say bye now. It's time to bid a goodbye to our MySQL. So now one more thing we are going to do is, before we wrapping up this uh, direct action, we will see how can we use environment variable. We'll begin with, first we'll see what all containers we have. We have 3 containers. Docker ps, we'll do docker inspect to each container. We'll begin with load balancer first, and then we will find out the environment variables of load balancer, and we'll copy it and we'll paste it in our sticky note so that we can use it later. Where are the, yeah, here's some. We'll take some. That's more than enough. This is specific to nginx. We'll take them. So copy this, and here is our sticky note, and this is our nginx. I think it's on top. So here I'm gonna place our, yeah. So let's begin now. So let me directly enter into the container docker exec, and here it is it, that is interactive. I'll show that command one more time so that it will be pretty clear for you. Docker exec, option I interactive, option T terminal, sleeper is the name of the container. Here our container name is it, name of the container here is load balancer. I will enter. Sorry, one thing we are missing, that's bin bash, that is our shell. So now we are inside the container. You see that it's a container id, and this is the root user inside the container. Now let me say who am I. You see that is a root, and pwd, we are in root directory, root virtual directory of the container. So now what we're going to do is we'll start looking into the, so let's see path variable first. Echo, you see that, and let's see the, that's how environment variable works. Echo, and it is nginx version is fine. Nginx version, here it is, it's a 1.23.3, and we have package release. We'll see package, okay, something wrong. Let me copy this, copy that directly. So okay, package release, okay. Oh, it's, I typed it packer, not package, not package. That's okay. It's one and tilde and bullseye. So similarly we will do with let's come out of that and we will do the same for um, Docker PS. It's to the Wipro app also, and we'll see. So Docker exec and Wipro app, and before that I'll put IT, and finally we have bin bash. Yes, we are inside that. You see the container ID, and you see that root, and this is the this is the working directory of that image. So let me do the pwd. You see that user local tomcat. So okay, similarly you can give some ls. You can find out the running.txt web apps notice logs. So these are the files inside that, and cd, sorry, just let me do the exit, and docker inspect and wipro, and I should find out. Yeah, here it is. Yeah, yeah. Path, Java home. So GPG keys, copy this and paste it here. This is Wipro. Yeah, yeah. So let's begin with the path we have seen. And path for Java varies, and path for Jenkins is different. Everything is different. You just want to know the path of that, you can get it from here. So, but before that, let me get into that. So it is our Docker exec. Okay, I have it. Yeah. So let me do echo and paste it here. So path, you see that? User local tomcat bin, and here you will find your path of that uh, Wipro app. And similarly, this time we are gonna look into Java home. Let's find a Java home because Java home is useful when you are working on Jenkins. So this is other way of getting the Java home. You see that opt Java open JDK. So now let's look into one more environment variable. This time language LLC Java version is fine. And then we can get the JPG key also that we are going to do. And Catalina home also we can check if you want. These are environment variable. These are predefined variable. You see that it's JDK 11.0.7 plus 8. And this time we are going to look into what's that? Catalina home. It's normal. So let's GPG keys and we'll see. Here it is. Here it is. This is your GPG keys. So this is how we use environment variables, and this is how we enter inside the container. This is how we play around inside the container. But let me exit from here, and we are gonna do Docker inspect for DB1. That's our SQL database. And let me scroll up and find out some of the environment variables and do a bit of game here. So these are very important, these environment variable, and you can attach more environment variables with that also. So Docker exec. Okay, before that let me paste it here. uh, I think it's yeah, here let me paste it here. So Docker exec it, and this is db2, and here what we have is that's a bin bash. What else? So there is no bin bash. Then, oh sorry, one. Yes, inside that bash 4.4. So now let's do echo, and what's that? Let's begin with gosu or path would be different completely because this is different. And gosu version will begin with gosu version and exit and enter, execute it. So you got the version, and similarly you can get it other information about that, which is the workbench. What version of the workbench you can get? Cell version we'll see. Workbench and all that we know it's 8.4 major, but we'll look into the shell version so that we can get more clarity about that. So paste, let me paste it here. So here it is. That's how 8.4.32 hyphen 1.8 LH. Okay. So let me exit from this. So with this, we have successfully demonstrated the exec command, and we have done the direct action into 3 containers. I hope that's more than enough for us. I hope you will also explore more than that. We have done the direct action on the container, that is exec, and then now we will do housekeeping or housekeeping using kill command as well as stop command, and we'll see the distinction between each other. So if the state of a container is important to you when it terminates, you may want to understand the distinction between docker kill and docker stop. So this distinction can also be important if you need your application to close gracefully in order to save data. So let's look into the docker kill use case first, then we will go for the stop. So docker kill, the problem statement here is you want to cleanly terminate a container, cleanly, completely remove all the respective data. So solution for that is docker kill, obviously the command that is docker kill. So the crucial point of docker kill is, so the crucial point to understand is that docker kill does not behave the same way as the standard command line kill program. So the program kill works by sending a term also known as a signal value 15 signal to the process specified unless directed otherwise. So this signal indicates to the program that it should terminate, but does not force the program. So most programs will perform some kind of cleanup when this signal is handled, but the program can do what it likes, including ignoring the signal. So a kill KILL signal, echo signal value 9, by contrast, forces the specified program to terminate it. So confusingly, Docker kill uses a kill signal on the running process, giving the processes within no chance to handle termination. So this means that the stray files, such as files containing running process IDs, may be left in the file system depending on the application's ability to manage state. This may or may not cause the problems for you if you start up the container again. So even more confusingly, the docker stop command, one more command, the docker stop command acts like the kill command, sending a term signal capital T, capital E, capital RM. So the commands normally we use, and the default signal that it sends is, if you use kill, it's term signal. That's the normal kill. That is, we use it in command line interface, the CLI, that is kill, command line utility kill, that uses default signal 15, whereas the docker kill, that uses default signal kill and then value 9, whereas docker stop, it uses default signal term, whereas the signal value is 15. So docker stop is equivalent to kill, whereas docker kill is slightly different. The difference is it forces the specified program to terminate a kill, whereas docker stop, it will not force it to terminate completely. So you can restart it. That's what we are going to show. So in summary, don't use docker kill and you would use kill, and you're probably best of getting into the habit of using docker stop. Obviously, so far we have been using docker stop, not even a single time we have used docker kill, if you are following my video. Okay, so we're gonna use docker stop, not docker kill, but we would like to know what it is. So list of docker machine commands, we know: create, ls, stop, start, restart, rm, kill, inspect, config, ip, url, upgrade. So inspect we have used, kill we haven't used, it kills a machine off. RM we have used, it destroys a machine. Restart to stop and starts a machine. And if you use a stop, just stops the machine. We have used docker stop, we use docker start, we use docker restart, we have used docker RM. Docker kill not it used. Inspect we have used, config, IP, URL, upgrade. That we are going to use. Okay, and create. So now let's get into the action. So here is my clear sudo I clear the screen and docker ps. 3 containers are running. Okay, 3 containers. So now let's demonstrate. So, docker create is to create a new machine, so we are not worried about that. If you do docker ls, so docker ls is not a docker command. So then we have docker stop to stop it, and docker start to start, and docker restart we have to mention. Docker restart to restart the container, and docker rm to remove the container, and docker kill to kill the container. Okay, and docker inspect we have used. So let's see, docker config and db. You see that here. So docker config command and manage docker configs. You create a config from a file, or inspect display detailed information on one or more configs, or ls list configs, or rm remove or more configs. This is how you can use a docker config command. And or else you can use docker ip. So docker ip returns the ip address of the machine. So docker ip, and it's db. And similarly, you can have docker url and docker upgrade. So but now here we are going to see docker kill. Okay, but before that let me check docker ps, docker kill, and it's db1. So db1 has been killed. So let me check docker ps. So only 2 containers are running, up and running. That is Wipro app load balancer. Now let me do docker psa and cross check here also. Node, you see that it's kubecheren db1 and db. Okay, it's been killed. It's been killed. So docker start and db and docker ps. Here it is. Okay, so that's how our kill works. So let's get into the work. Let's get into the docker stop now. So here it's finally, we'll use docker stop as we have discussed. We will use docker stop to do the housekeeping. So a frequent grip of new docker users is that in a short space of time you can end up with many containers on your system in various states, and there are no standard tools for managing this on the command line. So for that we'll do process substitution in bash if you have not seen it before. So you can do the process substitution. So if you want to prune the containers on your system, so set up aliases to run the commands that tidy up the whole container. That's what they call process substitution in bash. Okay. So the simplest approach here is to delete all containers. Obviously, this is something of a nuclear option that should only be used if you are certain it's what you want. So let's look into that command. If you do that, docker ps option A, option Q, Docker PS option U, it will throw you all the containers to you and Q. So get a list of all container IDs, both running and stopped, and pass them. Let's do that. Okay, for that, let me make this. I think this is enough for Docker PS option A, option Q. You see that? You see that? All the container IDs. All the container IDs have been got it. So now when you say xarg no run if empty docker rm f, the docker rm and option f command which will remove any containers passed even if they are running. That's the issue. Okay, so we don't want that. We don't want that. If you want it to be done as a step process, so to briefly explain xargs, it takes each line of the input and passes them all as arguments to the subsequent command. We have passed an additional argument, that is option no run if empty, which avoids running the command at all if there is no output from the previous command in order to avoid the error. This is how you can keep your house clean automatically. So if you have containers running that you may want to keep, but you want to remove all those that have exited, you can filter the items returned by docker ps command that we are going to do now. So let me bring it here. So here, if you look into this example, so you see the filter option. The filter flag tells the docker ps command which containers you want returned. In this case, you are restricting it to containers that have exited, only exited state. You can see that filter and status is equals to exited. Other options are running and restarting. You can put either status is equals to running or restarting, and you can specifically remove. You see that rm here, you can specifically do the docker rm to the either running or restarting, whatever you want, but you can remove it with one command. So this time you don't force the removal of containers because they should not be running based on the filter you have given. So let's get into the action again one more time. So this time we'll say again docker ps a option q, and now I want to filter it. Filter, and the status is exited, and make a pipeline and then enter into the new line or keep it the same line. So x args and option again no run if empty, do docker rm error response from daemon invalid filter. Okay, that's fine. So I got it. Sometimes it happens when you're typing the code. So it's done. It's been removed. So let's cross check docker ps option A. So now there is no container which is stopped. All are running container. So what I'm going to do is now, so we will build a container. We will run a container and we'll stop that container. Of course, let's check db1 is running at this moment. We'll stop this container and we will see whether this is working or not. Docker, wait, docker stop and or else we can kill it also, not an issue, but we'll stop it. dp1. So now let's do docker ps. So only two containers are spinning at this moment. So let me check docker ps option a. Okay, pd, not pd, it's ps. Docker ps option a. So now we have three containers. One is in exited status. You see that status is exited. Status is exited. Other two are running. So now we have to remove this one only. I want running containers to be stay same. So let me do that. Let me do docker ps again. And here it is gone. The exited container is gone. This is how the command is useful to delete, to keep your house clean. So you may need this if you have many containers on your system and want to automate the examination and removal of any containers that exited unexpectedly. So this is so if you take com option 3 runs the com command. This is comm command to compare the contents of two files. The option 3 argument suppresses lines that appear in both files, those with a 0 exit code, and outputs any others. Okay, it's for comparison, com comparison. Then finds exited container IDs, sorts them and passes them as a file to com. Then finally xorgs again comes into the picture, runs docker inspect again against containers with a non-zero exit code, uh, and saves the output to the error containers file. And it finds the container with an exit code of 0, sorts them and passes them as a file to com. Okay, so this is a bit advanced that we are not going to do. If you want to go like if you have huge amount of containers and you want to completely automate the process, and this is how you can use it. If you would like to explore more, I would always encourage you to explore more. But by the time, what I will do is I will get into our server and I will clean up the server. I'll do the housekeeping and then we will wrap up this. Okay. So Docker PS, two containers are running. Docker images, three images are there. So let us stop the container first. Only stop, no kill. No killing, no violence. Only peace, peace, peace. Shanti. So Docker stop, and what we have is mm, we'll start with what's the name, Wipro. Yep, Wipro app. And other one is load balancer. Yes, so done, both were stopped. Now let's check the status. Docker ps all gone. Let us get into the docker ps option here. Is gone, they are gone. And let's remove this. For that we'll use the same command again. See, I don't like to use this command, so that's the reason I did not use it. Which one? To remove all the containers which are running. I just want to show you that. That's it. I don't like to use it and I won't use it. I delete only the stopped containers. So that's why I'm repeating the same command. So done. These two containers were also removed. Now let's check. We should not have any container. Done and dusted. It's gone. Okay. So now let's cross check Docker images. Three images we have. Let's remove all of them. Cube, MySQL version. Okay. Docker RMI, MySQL, and it's Nginx and Cube. What is that? It's multi. Yeah, it's done. Oh, all has been deleted. Even each and every image, all layers has been deleted. Let's cross check Docker Docker images. Here it is. The house has been cleaned. The house has been kept clean. It's neat and tidy. So now it's time to click get out of that server and get into our slide. So with this, we have seen in this session, we have seen housekeeping, we have seen kill, we have seen stop, we have got to know how to automate the process of removing the containers, and also we have seen inspect and other commands. This is what an exercise that we have done in this session, that is housekeeping, kill versus stop, but we have done more than that. We are going to look into a few more advanced concepts of Docker, like the difference between the command cmd and then entry point. So we will look into these differences, and with this we are going to wrap up our Docker containerization video. So let's look into the entry point. The configuration management is the art of managing your environment so that they are stable and predictable. Tools such as Chef and Puppet have attempted to alleviate the system admin burden of managing multiple machines to an extent. So Docker also reduces this burden by making the software environment isolated and portable. Even so, configuration management techniques are required to produce Docker images, and it's an important area to be aware of. As you get more experience with Docker, these techniques will give you more tools for building images for whatever configuration needs you're trying to satisfy. So now let's create a reliable bespoke tools with entry point. So we will begin with um, entry point use case. So here in this case, Docker's potential for allowing you to run commands anywhere means that complex bespoke instructions or scripts run on the command line can be pre-configured and wrapped up into a package tool. So the easily misunderstood entry point instruction is a vital part of this. So we are going to see how it enables us to create Docker images as tools that are well encapsulated, clearly defined, and flexible enough to be useful. So in this case, problem statement is you want to basically we want to define the command the container will run, but leave the commands arguments up to the user. Okay, our problem statement is we want to define a command that container will run, but it should provide a space so that the commands arguments can be given by us. Okay, and the solution for this is use the Dockerfile entry point instruction. Till now we have used so many times cmd, but we haven't used entry point instruction. Now we are going to use entry point instruction, and we'll see the difference between cmd and entry point, and then entry point and cmd both together. So as a demonstration, we will imagine a simple scenario in this. In a corporation where a regular admin task is to clean up old log files, often is a prone to error and people accidentally delete the wrong things. So we are going to use a Docker image to reduce the risk of problems arising. So you can see the following script. So it deletes logs or a certain number of days old where the number is passed in as a command line option. You can see that. So it's a bin bash and then echo, and the number is given. Note that the log cleaning takes place on the /log dir folder. So this folder only exists when you mount it at runtime. So you may have also noticed that there is no check for whether an argument has been passed into the script. So the reason for this will be revealed as we go through the technique. So now let's create a Dockerfile in the same directory to create an image with the script running as defined command or entry point. So from Ubuntu, that's our base image. Then add, that's copying the log files from specific directory. Then run chmod, give the permission for basically give the execute permissions, and then entry point. So this is the command and argument will be left, or else there is one more. You give the command and an argument can be given through cmd. Either way it works. We are going to do example and we'll see uh, more clearly regarding the same. This command says add the previous corporate clean log script to the image, and entry point, define the entry point for the image as being the clean log script. Then the cmd defines the default argument for the entry point command, that is 7 days. So the difference between entry point and cmd often confuses people. So the key point to understand is that an entry point will always be run when the image is started, even if a command is supplied to the docker run invocation. If you try to supply a command, it will add that as an argument to the entry point, replacing the default defined in the cmd instruction. You can only override the entry point if you explicitly pass in an entry point flag to the docker run command. So let's look into the example so that we can get a concrete understanding in spite of just discussing in this way. So let's get into our machine. Just let me do SSH. So do I clear the screen? So Docker images. So Docker server has been kept clean, so nothing is there inside that. So now let's get into the cd home lscd ubuntu ls. Here we're gonna create mkdir, and we will create a directory saying mkdir docker exe13 and cd docker exe13. So here we're gonna write the first one. We are going to look into command. So inside that, mkdir cmd cmdx. So cmdx. So nothing is there. Now it's time to write our first docker file for cmdex. So vim as usual docker file. Let me click I to insert, and let's begin. We will take the Ubuntu from Ubuntu, and latest tag is absolutely fine. Then let's do this cmd. So cmd, when you use a cmd command, you have to give both your command as well as an argument. So let me give the command first. It is echo. Echo is our command, and comma, and hello is our argument. or another way is this is the best way to put it. Okay, so that's it. Our file is ready with the cmd. So the thing that you should observe in this case, cmd requires an command as well as an argument, and you can put an options also. Okay, so this is by default. Okay, so let's let's save this and quit it. So ls, here is our docker file. Now let's build the docker image from this docker file. So for that I would say docker and build and tag directly, and I'll say this cube print. Okay, just a minute. cmd print version 1 and dot. This is, here we have the docker file, so let me execute it. Sending build context to docker daemon. It's pulling the base image, and step 1 is done, step 2 is also done. Step 2 you can clearly see echo Hare Krishna. So unless you run the container, it's not possible. It can't be printed. Okay, so let's check the images. Docker images, you see that you have your image ready with it. Okay, so now let's run it. So docker run, name I'm gonna give cmd cont or container. cmd container, or just for fun we'll have printainer, cmd printainer. Okay, print plus container printainer, cmd printainer. Then it's not required. Okay, so docker run, name cmd printainer, and then image name. We're gonna provide image name is directly copy this and paste it here with the tag v1. That's it. You see that it's been printed Hare Krishna. So the command and then argument both has been attached in the same. So now it will be exited. It will be an exited state. You see that it is an exited state. Clear? So that's what the cmd is. cmd is, so the command as well as argument, that is echo and argument, both has been given. Let me show that. So command cmd, the difference between entry point and cmd often confuses people. The key point to understand is that an entry point will always be run when the image is started, even if a command is supplied to the docker run invocation. If you try to supply a command, it will add that as an argument to the entry point. This is the main difference that we are going to see. Whereas cmd should consist of both. It requires both a command as well as an argument. So now let's look into cd get back, and let's look into entry point. Now it's time to jump into the entry point. Okay, so mkdir and entry x cd, clear the screen, vim Dockerfile, insert. As usual we'll use from Ubuntu image latest. Now in this case for entry you can only have entry point and square bracket inside. Let's give echo. That's our command. That's it. And WQ. Save and quit. So now it's time to build an image. But what happens while we are building an image, that we are gonna see. So let me say Docker build option T, and this is entry printer version 1, and present working directory is where we have our okay 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 yep, done. So now it's getting built. So from Ubuntu latest, then entry point echo, so running, so successfully built. So now we have to run our container to give an argument. Okay, so entry point command has been attached. Now when you spin the container, the command will ask you for argument. Let's spin the container. So before that, let's check images. Here it is. This is cmd print, this is entry print. So let's spin the container. Docker run name. This time I'm gonna give, sorry, entry printer, entry printainer, and name of the image. Let me copy paste exactly with the tag v1. I think it's copy and paste it here. Okay, done. So it's gone. Come empty space. It's empty because you did not give any argument. So let us look into the Docker PS option A, and you see that your container echo without an argument. See that there is no argument. It has printed an empty space. So now let me run it again. So Docker, but this time I would say version 2. After version 2, I'm gonna say Hare Krishna. Okay, what's that? Oh, sorry. So I've changed the version of image, tag of image. That's my bad. Tag of image should remain same, and I had changed the name of the container to 1. Okay, because we have, see, Hare Krishna. So let's look into the Docker PS option A, and here you can see that entry printer container 1, that is this, and echo is the command, and Hare Krishna has been taken as obviously an argument. You can give whatever argument that you want. I will run the same one more time. This time the argument that I'm gonna give is Rama. Version 1 remains same, and container would be 2. Entry printainer 2. Rest all remains same. Let's execute. You see that? Rama. Okay, next time we will give a bigger one. First let me change the container name, and This time I'm gonna say Atma Rama Ananda Ramana Achyuta Keshava Harinarayana. Okay, so this we're gonna give. So let's execute. Here it is. Atma Rama Ananda Ramana Achyuta Keshava Harinarayana. So that's how an argument can be given by the user for the entry, whereas for CMD the argument should be provided with the command. So now we have seen both. Now let's look into the uses of both in a same Docker file. So let me get back. ls clear screen ls. Now mkdir cmd and entry and execd cmd, yeah, ls. But before that I just want to reiterate the same point. The main difference between entry point and cmd is if you try to here this point, entry point will always be run when the image is started. That's common. When image is started, even if a command is supplied to the docker run invocation. Okay, so this we will see now. Both together we'll see. Okay, vim, and it's a docker file. Insert mode, as usual, we will write a file saying from ubuntu latest and come down. Now let's add entry point. Entry point is only argument, that is echo, and whatever you want to print that we will attach in cmd, that is cmd. It here I'm gonna say okay, yeah, Hare Krishna. So I will close the square brackets and it's done. WQ. So our Docker file is ready with the entry as well as CMD. So now let us build the Docker image. So Docker build option T tag and okay, then we'll add entry CMD print and version 1 and dot. It's done. 3 layers, 1 by 3, 2 by 3, 3 by 3. So entry point has been run using cache, and you can see that. And running for this one cmd Hare Krishna, and so it's been built. This is the image id and this is the image tag. So let me give docker images and you can see that on top. So now let's start executing. Let's run our container and see what's going to happen and clear the screen first before we're running the container. So I'll say docker run name, it is entry cmd, yeah, then printainer. Then after that we will give the image name. Okay, let me get the image name first. Copy this, clear docker images, yeah. Now you paste it and get the image name. This is the image name with the tag v1. So take a space and paste it here, attach a v1 tag, done. So it's been printed. So Hare Krishna, it's been printed. Let's look into the docker ps option here, and you see your container. It's entry cmd printainer. So now I'm gonna print. Now I'm gonna attach one more now I'm going to spin one more container, but this time I'm not going to take the default argument that is mentioned in the cmd. I'm going to give our own argument. Let's do that. So here I will attach our own argument, that is Maryada Purushottama. Okay, so let me execute and see what's going to happen. Yep, I has to change the image container name because one container is existed. Here it is. Here it is. Maryada Purushottama. That means the argument has been overridden. So that's what I was saying here. If you try to supply a command, it will add that as an argument to the entry point, replacing the note this point, replacing the default defined in the CMD instruction. So you can only override the entry point if you explicitly pass an entry point flag to the Docker run command. That we are not doing now, but the difference is pretty clear. If you want to override the CMD argument, you just mention that argument when you run the container. That's it. That will be overridden. Okay, that's the main difference between Docker entry point and Docker CMD. So Docker entry point will come up with an argument, will come up with a command, and Docker CMD will have a command as well as argument. So for entry point, you can give either argument through CMD, or you can manually input an argument when you spin a container. But even if the Docker file consists of an argument through CMD, that can also be overridden by manually inputting a argument when you spin a container. So let's spin one more container. So this time I'm gonna say Sri Hari, and rest all remains same. Let me change the container name. It's 2. Here it is. Here it is. So this time I'm gonna spin a container without any manual argument. Then okay, container name should be changed because we have a container. So 3. Now you see that Hare Krishna, the default argument that is mentioned inside the CMD. So this is what the fundamental differences between CMD and entry point. Now let's do reverse engineering of a Docker file from an image. So you may find yourself in a situation where someone has created an image with a Docker file that you have access to, but the original Docker file has been lost. What will you do in this kind of situations? So you have found ourselves, so we might have found ourselves in this position on more than one occasion. Being able to recover information about the build steps can sidestep a lengthy process of rediscovering them for yourself. So in this case, let's take a problem statement of we have an image and we want to reverse engineer the original Docker file. So for that, the solution what you want to use is use the Docker Docker history command and inspect layers to try to determine what changes had been taken place. So although it is impossible to completely reverse engineer a Docker image in every case, you have a good chance of working out how it was put together if it was substantially created with a Docker file. Hopefully, enough of a chance to reconstruct the image sufficiently for your purposes. In this technique, that's Docker history technique, we are going to use the following Docker file as an example that I'll show you on the screen. Yeah, here you can see on the right side this Docker file we are going to use. So it contains as many as different types of instructions as we could fit in the shortest number of steps. You are going to build this Docker file, then run a simple shell command to give you an idea of how the technique works, and we'll finally look at a neater Dockerized solution. So let's write a Docker file for the same. So let's get into the action. Why to wait? Okay, before we begin this exercise, let me let me push all the Docker images that we have created in our last example into the Docker Hub. So let me check Docker images. These three. Okay, let me say Docker push cmd done. Access requested access to the resource is denied. Docker login. Okay, login succeeded. So let's push it. Okay, first image has been pushed, and similarly second image Docker push cube, this time entry, printer, and tag. So the second image also has been pushed. Now it's time to push the third image, that is again entry cmd print tag version 1. So let's get into that and we'll cross check. So this is my repository, and here you should see, yeah, all three. You could see that you should see all three. 1 2 3. Fine. So that's it. This major activity is done. So now let me get into cd home ubuntu ls cd docker exercises ls, and then just come out of this and create reverse engineer mkdir docker rev engineer. So ls cd docker rev engineer. Yes, so nothing is there. Let me write our docker file vim, and begin with from. But before that, let me get into the Docker hub, go to the explorer, and look for busybox. Yeah, which tag would be better? Shall I go with the latest? Get into the tags first. Yeah, latest one is there, no problem. Yeah, we'll go with the busybox latest. Absolutely fine, no issue. Okay, I'm going with the busybox and latest tag. Then maintainer is deprecated, but still I'm gonna give maintainer, that is cherry rams 127 at the rate of gmail.com. Then env. So I just want to put uh, maximum instructions possible. So env sorry, my env name and my env value. So I could just give name and value, but here I'm not mentioning that. So label, okay. What I will do is I'll randomly give some env. We'll define env. Okay. Label. This is team AI and work there opt run, just want to run, make there using parent and copied. So copy the docker file, just a minute, yeah, docker file to the copied docker file, then run again mkdir p added, and finally add docker file and added docker file. Then let me run one more command, that is touch and tmp file, then add docker file, expose this to 80 and volume data, and on build touch it and tmp and build entry point. So our command, that is bin bash and cmd are recursive, and let it open for an argument. So now let's save this and build this image. So docker build option t tag, that's cube Charan reverse engineer docker and version 1 dot and click enter. Sending build context add requires at least 2 arguments, but only one was provided. So vim dockerfile, where is add here it is. Okay, this is the mistake one, let me get into that. Add dockerfile and /hood dot. Okay, it's started building our image. So finally successfully built, successfully tagged. So now let me do docker images. Here it is, docker reverse engine docker. So our image is up and our image has been built, and with this tag id and with this, so all instructions has been executed cmd. So now let me get into here. So we have built it. So now we have to reverse engineer. It's time to reverse engineer the Docker file now. So a Dockerized solution. So if you run this, the Docker in practice from the image, you can reverse engineer that. Okay. So let me get into that. And let me give Docker history and a reverse engineer with tag 1. Here it is, here it is, here it is. Exact complete file with each command. cmd hello, entry point, bin bash, on build touch, volume data, expose, add file, add tmp, add file, p added, copy file, work there, label, name, maintainer, cmdsh and add file. So almost okay, one is missing, that's fine, but each and every command that we have written, we can literally see if somebody wants to build somebody wants to rewrite a file which is missing, which is a if they want to rewrite a docker file for a missing docker file of an image, so docker image, then you can literally use this docker history command to rewrite the docker image, docker file for the docker image. So now let me clear the screen and let's do more. So docker history and let's check for others. Let's do the ubuntu then and we'll see what's gonna happen. Ubuntu latest, you see that cmd bin bash, add file, then after that label org dot open containers of ubuntu, then org launch pad build org and release. So similarly we will do it for okay, docker images, and we can do it for this also. Let's docker history and cube cmd. Yep, here it is. So whatever we have done so far, cmd echo hare krishna, and what it has used bin bash and add file a label. That's because from here it's ubuntu. From here the first command is the last command that we have written in our docker file, and these are from base ubuntu image, so all these commands has been pulled. And similar thing can also be done for the other containers. I hope you will do it and I will take a leave from this session. So now we will look into uh, a concept called how can we integrate a configuration tool with Docker, like likes of Chef with Docker, likes of Ansible with Docker. That's what we are going to explore at this moment. So building images with Chef Solo. So one of the things that confuses newcomers to Docker is whether Docker files are the only supported configuration management tool and whether the existing configuration management tools should ported to Docker files. Neither of these is true. So although Docker files are designed to be a simple and portable means of provisioning images, they are also flexible enough to allow any other configuration management tool to take over. In, in, in short, if you can run it in a terminal, you can run it in a Docker file. That's it. If you can run it in a terminal, you can also run it in a Docker file. As a demonstration of this, we will show you how to get up and running with Chef. So arguably the most established configuration management tool. Arguably, not actually. So in a Docker file, using a tool like Chef can reduce the amount of work required for you to configure images. problem statement for us here is you want to reduce a configuration effort by using chef. So solution for that, we will install chef in our container and run recipes to provision it. And if we have a lot of recipes, then it will become a playbook or cookbook. As it is a chef, it's a cookbook. If it is Ansible, it's a playbook. So in this example, we are gonna provision a simple hello world Apache website using chef. So this will give you a taste of what chef can do for your configuration. For this example, we are using chef solo, which requires no external chef server setup if you are already familiar with chef. So this example can easily be adapted for your pre-existing scripts. So I'm gonna walk through the creation of this chef example, but if you want to download the working code, you just visit the git repository that I will provide the link in comment section. Okay, so we will begin with the simple aim of setting up a web server with Apache that outputs hello world when you hit it, when you run it. So the site is going to be served from mysite.com, and a mysite user will be set up of the image. So to begin, let's create a directory and set it up with the files you will need for chef configuration. So this is how mkdir chef example, then cd, then touch attributes.json, and you provide all the information. Then you write a touch Dockerfile, and let's go through each of the activity in this. So we have touch attributes.json, so we have to write this file, the chef attributes file, which defines the variables for this image or node in chef parlance, will contain the recipes in the run list for this image and other information. Then we have touch config.rb. So the chef config file which sets some base variables for the chef configuration. Then we have a Docker file, the Docker file that will build the image, and we have a cookbook with recipes. So this create the default recipe folder which stores the chef instructions for building the image. And finally we have the cookbooks with default templates. It creates the templates for the dynamically configured content. So default attributes.json file looks like this, a run list, and inside that you have to provide the required recipes such as Apache 2 default, mysite default. So let's continue with building images with chef solo. So the files that we have created, that sets out the recipes that you are going to run, and the two Apache 2 recipes will be retrieved from a public repository that link I'm going to provide. So, and as we have seen attributes.json file. So similarly it looks like that. So this file, the attribute.json file, sets up basic information about the location and adds the configuration security configuration setting and verify API certificate to suppress an irrelevant error. So let's go through the complete file. Here it is. So creates a mysite user, then it's sent. After creating a user, let's create a directory for the web content. So that's what the directory user, and then directory, and then template defines a file that will be placed inside the web folder. This file will be created from a template defined in the source attribute. Once this is done, then web app, define a web app for Apache 2 and all the placement and location into the hosting directory is also being done. And then so in a real scenario, you would have to change these references from my site to your website based on if you use your web applications, you have to change. The rest all remains same. So finally, you put everything together with the Docker file, which sets up the chef prerequisites and runs chef to configure the images as shown in this listing. That's it. Our image is ready. Sorry, our Docker file is ready on right side. You can see that from Ubuntu run apt get update and apt get install git curl. Then you have to fetch the repository. Then you have the copy the chef. We have chef solo already been installed in our server, and remaining will go as it is based on the config files. Then you do docker build and name of the image is chef example. Then you do the docker run tip port mapping with 8080 to 80 of the 8080 of the host to the 80 of the container, and name of the image is chef example. That's it. Once it is done, you should be able to see. If you navigate to this http and then public ip of the public ip of the instance and then port number 8080, you should see your hello world message. So although this is a trivial example, the benefits of using this approach should be clear. With a relatively straightforward configuration files, the details of getting the image into a desired state are taken care by the configuration management tool. This doesn't mean that you can forget about the details of configuration. Changing the values will require you to understand the semantics to ensure you don't break anything. But this approach can save you much time and effort, particularly in projects where you don't need to get into the details too much. So, with this, we have reached to the end of the first video of Docker part, that is Docker containerization. In this, we have covered a lot of topics and we have done a lot of examples, lot of exercises. I hope you enjoyed each and everything. Let me sum up everything. We have begun with life before Docker and life with Docker. Then we have moved to the history of the Docker. Then we have seen the complete comparison, how the three times of effort life before Docker has become one time effort life with Docker. Then we have seen the advantages. Then we have seen the benefits of Docker image, using a Docker image, how you can build a lot of containers from single Docker image, and that's what we have seen. And after that, we started writing our own Docker file, and we started building our own Docker images, and we started pushing our Docker images into the Docker Hub, and we started using those pushed Docker images again and spin a container. So this is what we have done. After that, we entered inside the engine room and we have explored each and every component of Docker and Docker engine. Then we have completely understood the Docker architecture, Docker engine architecture, and how it connects with each other. And example, Unix domain socket and HTTP request response and Docker client, Docker daemon, and docker.sock. So everything we have seen with a lot of examples. And finally, we came to day-to-day Docker, where we have discussed about the data persistence, volume mount, bind mount, and even data container and NFS. A lot with examples. Everything is with examples. Then finally we move to configuration management. There we have seen the difference between entry point and command, and we also looked into the reverse engineering of the Docker file and Docker image, reverse engineering of the Docker image, and finally we also seen the difference between a kill and stop, and we have done enough of housekeeping. I hope you enjoyed it, because this is very important tool nowadays, irrespective of you're a data scientist or a DevOps engineer or software engineer or an ML engineer. Irrespective of your designation, Docker is the minimum requirements. I've seen in plenty of job descriptions. It's a bare minimum requirement these days. That's why I have given a lot of examples, so that you can easily learn it. Okay, if you want anything, if you want the files that I've used in this example, you just ping me on comment section. I will provide you complete GitHub repository from where you can get each and every file that I have used in these examples. I hope you enjoyed it. If you enjoy it, keep liking it, keep subscribing it, keep spreading it, keep telling everybody, so that everybody can get benefit out of it. And until then, bye bye, see you. Keep loving me, keep liking me, keep subscribing. Thank you.